compute the cross product between the vector a equals 3i plus j plus 2k and the vector b equals 4i minus j plus 6k. So we want to work out a cross b, or in component form, the vector 3, 1, 2 crossed with the vector 4, minus 1, 6. And the method that we will use is the 3 by 3 determinant method. So remember, this is this process where we're going to write a block of numbers. The first column of this block is going to consist of the three standard basis vectors I, j, and k. The next column is going to consist of the components of the first vector in the cross, 3, 1, 2. And the final column will consist of the components of the vector, the final vector in the cross, so 4, minus 1, 6. Remember that this is shorthand for another algorithm. It's shorthand for I times what's called a 2 by 2 determinant minus j times another 2 by 2 determinant plus k times a third 2 by 2 determinant, where these small blocks of numbers, 2 across, 2 down, are found by crossing off the rows and columns that contain each of these guys. For example, to find the determinant that corresponds to I, we'll cross off the row and the column that contains the standard basis vector I. That gives us the block 1, minus 1, 2, 6. To work out the determinant that's connected to the vector j, we'll cross off the row and the column that contains this to get the block of numbers 3, 4, 2, 6. And finally for k, we'll cross off the row and column that contains the vector k to find the submatrix 3, 4, 1, minus 1. Now remember, each of these small blocks is again shorthand for another product. The product of the elements along the main diagonal minus the product along the counter diagonal. So if we were to work out each of these smaller values, we would have I times 6 minus negative 2 minus j times the main diagonal, 18, minus the counter diagonal, 8, plus k times the main diagonal, minus 3, minus the counter diagonal, 4. If we were to clean these up, 6 minus minus 2 is 8 times the vector I. 18 minus 8 is 10, so we have a negative 10j. And minus 3 minus 4 is negative 7. And so there is our cross product, 8i minus 10j minus 7k. In component form, that's 8 minus 10 minus 7, or in column form, 8 minus 10 minus 7. And any one of these is an acceptable answer. One of the useful things that you can do is check whether or not this vector is correct by taking its dot product against the two original vectors used to find it. It should be orthogonal to both. So let's test this right now. Let's take our cross product and dot it against these two vectors. If we take 8 minus 10 minus 7 and dot it against the first vector, we end up with 24 plus negative 10 plus negative 14, which is exactly 0. If we take 8 minus 10 minus 7 and dot it against the second vector, we obtain 32 plus positive 10 plus negative 42. 32 plus 10 minus 42 is also 0. So this vector is indeed orthogonal to both, and that's a very good check.